Shortcuts. Oh, I love shortcuts. Shortcuts is what you guys should be figuring out as we're working through our thinking tasks. And so this video is a summary of the shortcuts that I was hoping that you guys would start to take notice of as we work through our thinking tasks. And so you'll notice that the 2s stay the same, the 1s stay the same. Over here, the standard forms of these guys, they change a little bit because of the squaring and the A's that are in front here. Here the A is 1, here the A is 3, 1/3, and then -3. I want to show you guys what those do to the graphs. Okay, and I'll keep referencing the mother function graph, which is x squared, and it looks like this. First, let's look at the one that has an A that equals 1. Here I have the two forms. I have vertex form and I have standard form. And what I want to first do is identify the 3 most important characteristics of our quadratic function, which is the vertex, and then the axis of symmetry, and then the max or min. Here our vertex is right there. That vertex is 2, 1, and you can see very clearly in our vertex form where those numbers come from. Notice this is a +2, not a -2. You don't really see that in the standard form. The axis of symmetry is right down the middle of our parabola. That is x equals 2, related to the x in the vertex and the 2 that you see in vertex form. And then we have our minimum value. Our minimum value is always a y value, and in this case it's a minimum, not a maximum, because we're at the bottom of this parabola right here. Okay, so how does the standard form relate to our graph? Well, it is pretty hard to see, but what you need to have the axis of symmetry formula. When you actually use the axis of symmetry formula, you will get the same axis of symmetry that you see right here in the vertex form. Okay, but you'll have to plug in the b and the a to find it. The b right here is -4 and our a is 1. And of course it's invisible because when you multiply by 1 it doesn't do anything. So when I plug those in, you get a 2. And then if you guys wanted to find the y value, you have to take that 2 and then plug it back into our function to get the y value. Okay, so when we graph, what you got to do is you have to first graph the vertex. So our vertex is 2, 1. Then the other thing you want to do is you want to graph a point right next to the vertex. After you graph that point right next to the vertex, you can copy it over to the other side because of the axis of symmetry. And so I have an axis of symmetry right here. I'll be able to copy this 1 point over to the other side, and then I'll be finished with my graphing. What is interesting to note here is that the a is 1 on our mother function, and the a is also 1 right here for the function f, also over here. And so what you see is that our point right next to the vertex is just 1 to the right and 1 up. Now you could go the other way too, but I chose to just go to the right and pick, for this function, I picked a 3 for the next number that I put in my table. Okay, and then I put my other points, and then I'm able to graph because of the axis of symmetry. Now, I chose that as my other point. You need to have a vertex and one other point in order to graph. If you didn't choose this as your point, if you didn't choose this guy as your point, you could have chosen the y-intercept. Now, the y-intercept is when you plug 0 into x. And this is the only advantage that standard form seems to have over vertex. When I plug 0 into the vertex form, I have to do a little bit more math than what I would have to do over here. Because here I can clearly see I have a 0 minus 0 plus 5. And so I know that my y-intercept is 5. Okay, and then you would be able to graph the other point and be able to graph the parabola. Now let's take a look at what happens when that a is a 3. So our g function right here has an a that is 3, but everything else is pretty much the same. The vertex is still 2, 1. The axis of symmetry is still x equals 2. And the max or min is 1. And in this case, we're still looking at a min. Okay. Over here for the standard form, if you guys wanted to find the axis of symmetry, you would have to plug in this -12 and the 3 into the b and the a. You would get 2, and then you would have to take that 2, plug it back into the function to find the y value. All right, so when we graph, this is what we're talking about a lot, is we start with our vertex, and then you pick an x value below it or above it. I am just going to pick the x value that is above it. So I'm going to erase the other one. And then if I plugged in 1 to my mother function, I would get Well, I'll tell you that in a second. Here's G. Here's my vertex. Below it and above it would be 1 and 3. I'm going to do 3 right now. Okay, so if I picked 1 over here for my mother function, I would get 1, and there my point would be. And then I would be able to see that it's still following that pattern, 1 to the right and 1 up. Let's look what happens over at my G function. If I plug in 3, I get 4, which actually is right 1 and then up 3. Okay, interesting, huh? That's probably because there is a 3 right here for the A. Then after you have that one other point, you can copy it over to the other side and you get your graph. I'm going to do the same thing over here on my G function, and then I got my graph. Now, if you didn't want to use that point right next to the vertex, you could instead use the y-intercept. To do the y-intercept, we've got to plug 0 into the x's. And over here for the standard form, we can clearly see that the y-intercept would be 13. Then you would graph that point, 0, 13. You'd be able to copy it to the other side, use the vertex, and then you got your point. So when you're graphing, all you need is the vertex and one other point. You could choose the easy point that's right next to the vertex, or you can use the y-intercept. Okay, so for my part 2 video, I'm going to show you guys what happens to the graph when we have a fraction, 1/3, and what happens when we have a negative a.